A wallet is less like a bank account and more like an authorization engine. An AI agent can propose actions, but private keys approve them. In this module, we'll look at how signing enables automation without giving an agent unchecked control. You already have the core building blocks: agents that plan, call tools, remember context, and follow safety rules, plus blockchain basics like accounts, transactions, gas, consensus, and on-chain state. Now we'll connect those pieces through wallets, keys, and signing. Without a wallet, an agent can observe. It can read data, suggest actions, and call ordinary APIs. A wallet changes that role from advisor to actor. Once the agent can sign, its intent can become an on-chain transaction. It may update state, move assets, interact with contracts, or trigger payments. That is powerful, but it also raises the risk. Before granting signing access, design limits, approvals, and safeguards so execution stays controlled. A wallet is a key manager, not a container that holds tokens. The private key is the root secret. From it, software can derive a public key and, usually, an address, the account identifier others can see. Your coins and contract balances remain on the blockchain. When you send a transaction, the wallet uses the private key to create a signature, proving control of that address without revealing the secret. The private key is the master credential for a blockchain account. The network does not ask who is holding it. It only checks whether the signature is valid. If an attacker gets the key, they can authorize transfers, approvals, and smart contract calls as if they were the owner. Because these actions are usually final, leaked keys can mean permanent loss. Agent systems must protect keys like production root secrets. Private key storage is a trade-off, not a single best practice. Environment variables are fast for local builds, but they can leak through logs, repositories, or compromised servers. Secret managers and key vaults add access control, rotation, and auditability for production. Hardware wallets provide stronger isolation, but may block full automation. Test wallets keep experimentation separate from real funds. As agents become more autonomous, move from convenience toward controlled, observable custody. The model should never be a place where secrets exist. It can reason about intent, such as send this payment or approve this transaction, but it should pass that request to an orchestrator or wallet layer. That layer validates policy, asks the secure signer to sign, and returns only a result, such as a transaction hash. Prompts, memory, logs, and tool outputs should contain decisions and metadata, never private keys. Wallet practices should mature with the environment. In development, assume keys may be exposed. Use local and testnet wallets, keep balances tiny, and separate staging from experiments. If a key appears in logs, repositories, or shared tools, rotate it immediately. Production is different. Before agents can move real assets, require hardened wallets, access controls, monitoring, backups, and a clear recovery path. Every step toward mainnet is a step up in accountability. Message signing and transaction signing serve different purposes. Signing a message is usually a proof. I control this wallet, or I agree to this off-chain statement. It is common for logins, attestations, and approvals that do not change blockchain state by themselves. Signing a transaction authorizes executable on-chain action, such as sending ETH, paying gas, or calling a contract. Treat transaction signatures as higher risk, because their effects can be immediate and irreversible. A signed transaction begins as structured intent: the recipient, value, nonce, gas limits, fees, and any contract call data. Before signing, wallets often simulate or validate it because the signature is the account owner's authorization. After signing, the transaction can be broadcast. Nodes verify the signature, check protocol rules, and decide whether to include it in a block. Once confirmed, the transfer or contract call executes, and reversing the effect is usually not practical. Message signing proves wallet control without spending gas or moving funds. A server creates a challenge that includes the domain, nonce, timestamp, and purpose. The wallet signs that exact message, not a transaction. Then the application checks whether the signature matches the claimed address and whether the challenge is fresh. This is the basis of sign-in with wallet, and it lets agents prove identity off-chain in a controlled, auditable way. Before an agent signs, treat the request as untrusted until it passes a safety gate. Check the recipient, token amount, contract method, and chain ID against expected values. Apply policy limits such as allow lists, block lists, and spending thresholds. When possible, simulate the transaction to reveal hidden effects. If the action is high value, unusual, or outside delegated authority, pause for human approval. The principle is simple: no signature without verification. Traditional wallets are straightforward. Whoever controls the private key can approve transactions. Smart wallets add a programmable layer in between. Before anything executes, a smart contract can check rules, require extra approvals, enforce spending limits, or allow recovery if access is lost. This is account abstraction. The account is no longer just a key. For autonomous agents, that matters because we can delegate limited powers without giving them unlimited control. A session key is a temporary, limited credential for an agent. Instead of handing over the main wallet key, the owner grants precise permissions through a smart wallet. Those permissions might allow only one contract, only one function, no more than $50 per day, and only for 24 hours. That is delegated execution. The agent operates autonomously, but inside a sandbox. If behavior looks wrong, access can be revoked immediately. The core lesson is simple. Wallets give agents real authority. Keep private keys outside the model, distinguish identity proofs from execution approvals, and place validation, policy checks, and isolated signing between reasoning and action. Next, we'll use RPCs and SDKs to connect safely, call contracts, and practice on testnets.